Today we are going to see about programmable logic controllers, which is one of the popular controller used in automation industries. So we are going to see about history of programmable controllers, relay ladder logic, central processing unit, input-output system, programming and peripheral devices, programming concepts, applications, troubleshooting and maintenance. First we will see the introduction. The advantage of PLCs is less wiring. If you use relays, we did lot of wirings, but in PLC we need only very less wirings. Wiring between devices and the relay contacts are done in the PLC program, which is very easier and faster to make changes. Then troubleshooting aids make programming easier and reduce downtime. Reliable components make these likely to operate for years before failure. PLC origin. PLCs are developed to operate replace relays in the late 1960s, and at the time of 1960s the cost of the PLC is very high. After that cost dropped and became popular by 1980s. Now used in many industrial designs. Programmable controller development. 1968 programmable concept developed. In 1969 hardware CPU controller with logic instructions, 1 kilobytes of memory and 126 input output points. In 1974 use of multi-process within a PLC, timers and counters, arithmetic operations, 12K of memory and 1024 input output points. In 1976 remote input output systems introduced. 1977 microprocessor based PLCs introduced. 1980 intelligent input output modules developed, enhanced communications facilities and enhanced software features. Use of personal microcomputers as a programming aids. In 1983 low cost small PLCs introduced. 1985 onwards networking of all levels of PLC computer and machine using SCADA software. According to the NEMA standard, the definition of programmable logic controllers is a digitally operating electronic apparatus which uses a programming memory for the internal storage of instructions for implementing specific functions such as logic, sequencing, timing, counting and arithmetic to control through digital or analog modules various types of machines or processes. Some of the leading brands of PLCs shown here. One of the leading brands is Allen Bradley, Texas Instruments, General Electric and Westinghouse, Caterhammer. These are all American PLCs. And then some of the European PLCs, Siemens. Siemens is a very popular PLC. Second one is Locker and Muller, Festo and Telemechanic. And some of the Japanese PLCs, Toshiba, Omron, Fanuc and Mitsubishi are the popular Japanese PLCs. So areas of application: manufacturing, machining, food and beverage, metals, power, mining, petrochemical and chemical industries. PLC size depends upon the applications. PLC size will vary. Small, medium and large number of PLCs available. Small, it covers units with up to 128 inputs and outputs and memories up to 2 kilobytes. These PLCs are capable of providing simple to advanced levels or machine controls. Medium PLCs have up to 2048 input outputs and memories up to 32 kilobytes. Whereas large PLCs, the most sophisticated units of the PLC family, they have up to 8192 input outputs and memories up to 750 kilobytes. Major components of a common PLC processor. Processor is the main component. Then power supply, programming device, input module, and then output module. See here, processor is the main unit of the PLC. I can say processor power supply is the main heart of the PLC. I can say it is called CPU. Combinedly it is called CPU. Processor will have a microprocessor and memory unit. The power supply unit for memory as well as microprocessor. And in addition to this CPU, we will have an input module and output module. The input module is for giving inputs, field inputs such as sensors, push button and contactors. Whereas output module is to actuate the electrical loads. Major components of a common PLC. Power supply. The power supply units provides the voltage needed to run the primary PLC components. I/O modules. The I/O modules provide signal conversion and isolation between the internal logic level signals inside the PLC and the field's high level signal. Processor provides intelligence to command and govern the activities of the entire PLC systems. Programming device. The programming device is used to enter the desired program that will determine the sequence of operation and control of process, equipment or driven machine. Types. The programming device types are handheld unit with LED or LCD display, desktop type with CRT display, compatible computer terminal, or we can use laptop also as a programming device. I/O module. The I/O interface section of a PLC connects into external field devices. The main purpose of the I/O interface is to condition the various signals received from or sent to the external input and output devices. Input modules converts signal from discrete or analog input devices to logic levels acceptable to PLC processor. Output modules converts signal from the processor to levels capable of driving the connected discrete or analog output devices. DC input module. So the DC input module will have three sections. One is current limiting resistor, opto isolator and buffer unit. So here the current limiter resistor is for limiting the input current from the input device. Opto isolator is acting as a isolating device between your CPU and the input device. In case any fault in the input device that may affect your CPU, in order to prevent the fault current flowing into the CPU, the opto isolator is used to prevent the fault current entering into the CPU. AC input module. So if the field input device is DC, you have to go for DC input module. If the field input device is AC, then you have to go for AC input module. In the AC input module, there will be a rectifier unit because your CPU input is DC voltage. So we have to convert AC into DC. So from the input device, the voltage AC voltage will be converted into DC in the rectifier unit. That will be sent to the opto isolator. Opto isolator will convert usable DC voltage that will be fed to the CPU unit. So this is the opto isolator unit, in which opto isolator unit will have a light emitting diode and phototransistor. The light emitting diode will emit the light. The phototransistor will convert the lights into usable DC voltage. So this is the compartment which is inside the input module. Input module will have a more number of terminals. Each terminal will have this compartment. So DC and AC output modules, both combined in one single module. So this is the DC output model and AC output model. Same as input model, output model also will have a number of terminals, so that will convert CPU DC voltage into usable AC or DC output voltage. I/O circuits, different types of I/O circuits. First one is pilot duty outputs. Output of this type of typically are used to drive high current electromagnetic loads such as solenoids, relays, valves and motor starters. So these loads are highly inductive and exhibit a large inrush current. So pilot duty output should be capable of withstanding inrush current of 10 times the rated load for a short period of time without failure. Second I/O circuit is general purpose outputs. So these are usually low voltage and low current and are used to drive indicating lights and other non-inductive loads. The noise suppression may or may not be included in this type of modules. The third one is discrete inputs. Circuit of this type are used to sense the status of limit switches, push buttons and other discrete sensors. Noise suppression is of great importance in preventing false indication of inputs turning on or off because of noise. Fourth one is analog input output modules. Circuit of this type sense or drive analog signals. So analog inputs come from devices such as thermocouples, strain gauges or pressure sensors that provide a signal, voltage or current that is derived from the process variable. Standard analog input signals is 4 to 20 milliampere or 0 to 10 volt. The analog outputs can be used to derive devices such as voltmeters, XY recorders, servo motor drives and valves through the use of transducers. Standard analog input signals is 4 to 20 milliampere, 0 to 5 volt, 0 to 10 volt. I/O circuits. Fifth one is special purpose I/O circuits. So circuits of this type are used to interface PLCs to very specific types of circuits such as servo motors, stepping motors, PID controllers. This module allows for limited access to timer and counter, presets and other PLCs variable without requiring a program loader. So these are the examples of inputs and output devices. So push buttons and switches are the inputs. Outputs are contactors, motor, lamp. So this is a simple example of wiring connection between your PLC and the input device. And the right side one is ladder diagram. For the input, we have to create a ladder diagram. So the ladder diagram input is indicated by a contact, NO contact. So here we have connected our NO switch. So that will be represented by a NO contact in the ladder diagram program. We have to enter the address in the ladder diagram, then only PLC will understand the input which is connected to the terminal. So some of the discrete inputs. A discrete input also referred as a digital input is an input that is either on or off or connected to the PLC digital input. In the on condition, it is referred to as a logic 1 or a logic high, and in the off condition may be referred to as a logic 0 or logic low. So here first one is normally open push button, second one is normally closed push button. So normally open switch, normally closed switch. So here the contact is shown as a normally open contact. Last one is normally closed contact. So the normally open push button, normally closed push button is shown as here normally open contact or normally closed contact in the PLC program. So here you will see the logic, off logic. When switch is open, the logic is 0, it means off, switch is off. So PLC input module is 24 volt DC, there will be no voltage to the PLC input module. The second one is NC, so NC means closed condition. When you press the switch will be closed, so it became a logic 1, NC. Here it is a NC switch. So logic 1, the input is 24 volt will be sent to the PLC input module. Analog input. An analog input is an input signal that has a continuous signal. Typical inputs may vary from 0 to 20 milliampere or 4 to 20 milliampere or 0 to 1 volt. Below, a level transmitter monitors here in this. A level transmitter monitors the level of liquid in the tank. Depending upon the tank level, the signal to the PLC can either increase or decrease as the level increases or decreases. Digital output. A discrete output is either in an on or off condition. Solenoids, contactor coils, lamps are example of devices connected to the discrete or digital outputs. Below, the lamp can be turned on or off by the PLC output it is connected to. Analog output. So this is an example of analog output. An analog output is an output signal that has a continuous signal. Typical outputs may vary from 0 to 20 milliampere, 4 to 20 milliampere or 0 to 10 volt. Processor. The processor module contains the PLC's microprocessor, it is supporting circuitry and its memory system. The main function of the microprocessor is to analyze data coming from the field sensors through input modules, make decisions based on the user's defined control program, and return signal back through output modules to the field devices. Field sensors are switches, flow, level, pressure, temperature, transmitters, etc. Field output devices are motors, valves, solenoids, lamps, and audible devices. The memory system in the processor module has two parts, a system memory and a application memory. So memory design. Memory designs are of two types, volatile memory and non-volatile memory. So in the volatile memory, a volatile memory is one that loses its stored information when power is removed. Even momentary losses of power will erase any information stored or programmed on a volatile memory chip. Common type of volatile memory is RAM, random access memory. So read rate indicates that the information stored in the memory can be retrieved or read, while write indicates that the user can program or write information into the memory. Memory. The words random access refers to the ability of any location. That means address. So in the memory to be accessed, RAM memory is used for both user memory and storage memory in many PLCs. RAM memory must have battery backup to retain or protect the stored input program because it's a volatile type memory. Second one is non-volatile. So the non-volatile memory has the ability to retain stored information when power is removed, accidentally or intentionally. These memories do not require battery backup. Common type of non-volatile memories are ROM. This is the expansion of ROM is read-only memory. So read-only indicates that information stored in the memory can be read-only and cannot be changed. Information in ROM is placed there by manufacturer for the internal use and operation of the PLC. Normally, the PLC will have an operating system. The operating system will be stored in the ROM. Other types of non-volatile memory, programmable read-only memory, which allows initial and or additional information to be written into the chip. ROM may be written into only once after being received from the PLC manufacturer. Programming is accomplished by pulses of current. The current melts the fusible links in the device, preventing it being reprogrammed. So this type of memory is used to prevent unauthorized program changes. EEPROM. EEPROM is the erasable programmable read-only memory, ideally suited when program storage is to be semi-permanent or additionally security is needed to present unauthorized program changes. The EEPROM chip has quartz window over a silicon material that contains the electronic integrated circuits. This window normally is covered by an opaque material, but when the opaque material is removed and the circuitry exposed to ultraviolet light, the memory content can be erased. The EEPROM chip is also referred to as UV-PROM. EEPROM is the electrically erasable programmable read-only memory, also referred to be as E2PROM. Is a chip that can be programmed using a standard programming device and can be erased by the proper signal being applied to the erase pen. E2PROM is used primarily as a non-volatile backup for the normal RAM memory. If the program in RAM is lost or erased, a copy of the program stored on E2PROM chip can be downloaded into the RAM. Plc operation. So basic functions of typical PLC: read all field input devices via the input interfaces, execute the user program stored in application memory, then based on whatever control scheme has been programmed by the user, turn the field output devices on or off or perform whatever control is necessary for the process application. So this process of sequentially reading the inputs, executing the program in memory and updating the output is known as scanning. So we are going to see about the scanning cycles one by one. So while the PLC is running, the scanning process includes the following 4 phases, which are repeated continuously as individual cycles of operations. Phase 1. The phase 1 scanning cycle, the PLC will scan the input module, that is called a read input scan. So what are all the inputs connected to the input module that will be scanned by the PLC in the phase 1. Phase 2, program executions. So the PLC will scan the program in the phase 2. Phase 3, diagnosed communication. I mean whether the inputs, whatever the inputs is connected, whether the input is on or off, that will be verified by the PLC. Then the program will be accordingly executed. The last phase of the program is output scan. During the output scan, the updated input in the CPU will be executed in the output scan. So in case if you made any changes in the input or program during the scanning cycle, that will not be taken into consideration because the scanning is independent of the changes. So if any changes made in the program or input, that will be taken into consideration during the next cycle only. So phase 1, the input scan. A PLC scan cycle begins with the CPU reading the status of its inputs. Phase 2, the application program is executed using the status of the inputs. Phase 3, once the program is executed, the CPU performs diagnostics and communication tasks. An output status scan is performed at last. The output scan status is then whereby the stored output values are sent to the actuators and the other field output devices. The cycle ends by updating the outputs. As soon as the phase 4 are completed, the entire cycle begins again with the phase 1 input scan. The time it takes to implement a scan cycle is called scan time. The scan time composed of program scan line, which is the time required for solving the control program, and the I/O update time, or time required to read inputs and the update outputs. The program scan time generally depends on the amount of memory taken by the control program and the type of instructions used in the program. The time to make a single scan vary from 1 millisecond to 100 milliseconds. PLC communications. So normally we will communicate between programming device to the PLC. We will use communication ports. So changing resident PLC programs, updating, downloading and uploading from a supervisory control, we have to go for a communicating devices. So forcing I/O points and memory elements from a remote terminal, linking a PLC into a control hierarchy containing several sizes of PLCs and computer, monitoring data and alarms, etc. via printers or operator interface units. We need communication devices, communication ports. So these are the normal, usual communication ports used in the PLC communication. One is local area network, LAN. Local area network provides a physical link between all devices, plus providing overall data exchange management or protocol, ensuring that each device can take other machines and understand data received from them. LANs provides the common high-speed data communications bus which interconnects any or all devices within the local area. LANs are commonly used in business applications to allow several users to share costly software packages and peripheral equipment such as printers and hard disk storage. RS-230, RS-422 and RS-485 communication ports. These are used for longer distance links, often between several PCs in a distributed systems. RS-485 can have a maximum distance about 1000 meters. So these are the programmable controller networks, dedicated network system of different manufacturers. So Allen Bradley, the network is data highway network, Goodyear Modicum, Modbus, General Electric, GE Net Factory LAN, Mitsubishi, Mason Net, Square D, Cynet. So these are the network system of different manufacturers. Specifications. Several factors are used for evaluating the quality and performance of programmable controllers when selecting a unit for a particular applications. These are listed below. Number of input-output ports. So this specifies the number of input-output devices that can be connected to the controller. These should be sufficient input-output points to meet present requirements with enough spares to provide for moderate future expansion. Selecting a PLC. What are the criteria to select a PLC? First one is number of logical inputs and outputs. So it depends upon the number of logical inputs output only we can select a PLC, whether we need a small PLC or medium PLC or large size PLC. Then the memory, then number of special I/O modules, then scan time, then communications software. Based on these criteria only we have to select a PLC. A detailed design process. So first we have to understand the process, hardware software selection, develop a ladder logic, determine scan times and memory requirements. So PLC stator indicators, power on indications will be available in the PLC run mode, program mode and fault mode. Troubleshooting. So how to troubleshoot a PLC? Look at the process and check the PLC status lights. Halt. Something has stopped the PLC. If there is any indication, so each error will be indicated by a LED indication. So if there is any halt, something has stopped the CPU. Run. The PLC thinks it is okay. So probably is error. A physical problem has occurred with the PLC. Third one, indicator lights on I/O cards and sensors. Fourth one, consult the manuals or use software if available. Fifth, the user programming terminal or laptop. List of items required when working with PLCs. First one is programming terminal. A programming terminal is nothing but laptop or desktop PC. PLC software. PLC manufacturer will provide the PLC software and the license key. Communication cable for between your programming terminal and PLC will be connected by the communication cable. So we need a communication cable. Then backup copy of the ladder program. So that can be stored in a CD-ROM or hard disk or flash memory. If none, upload it from the PLC. Documentation, PLC manual, software and drawings. Examples of PLC programming software. So each manufacturer will provide software along with the PLC. So very popular PLC is Allen Bradley PLC. They will provide Rockwell software, RS Logic 500 and Modicon, Modesoft, Omron Syswin, G Func Series 6, Logic Master and Square D, Power Logic, Texas Instruments, Semantic and Telemechanic Modicon, TSX Micro. So these are the examples how to do the program. First one is a contact, normally open contact. Second one is normally closed contact. So power flows through the contacts when they are closed. Then the normally open is true when the input or output status bit controlling the contact is 1. The normally closed is true when the input or output status bit controlling the contact is 0. Coils. Coils are used for representing the output in the PLC ladder diagram program. So coils represents relays that are energized when power flows to them. When a coil is energized, it causes a corresponding output to turn on by changing the state of the status bit controlling the output to 1. That same output status bit may be used to control normally open or normally closed contact anywhere in the program. Boxes. Boxes represent various instructions of functions that are executed when power flows to the box. Some of these functions are timers, counters, and mathematical operations, and operations. So each rung or network on a ladder program represents a logic operations. In the rung above, both inputs and A and B must be true in order for the output C to be true. So here A and B are connected in series. If A and B are true, then only your output C will be enabled. OR operations. The logic gate OR operation. In this OR operation, two normally open connects are connected in parallel. If any one of the input is true, so if any one of the input is true, either A or B, then your output coil C will be enabled. In the rung above, it can be seen that either input A or B is true, or both are true, then the output C is true. NOT operation. So in the rung above, it can be seen that if input A is true, then the output C is true, or when A is 0, output is